Welcome everyone to open source Linux kernel driver development 101 here. DDR5 SPD 1518 or so, SPD SPD and sensor temperature hub. Part 3, initially we wrote this and we got some more patches, and now with release candidate 5 soon opens merge window there of upstream Linus Torvalds Unix clone fame, so that we need to finally spend some time actually finalizing that. And so one more thing, also the vastly underestimated overhead management time of actually working on all this stuff, right? Initially development, testing, more testing, feedback, merging and testing, more testing, and then polishing it for upstream. I anyway need to check with best, because usually I implemented small, contributed small things to the Linux kernel, and probably not new driver from scratch. Actually need to check with them how they want this, because now the thing is, in the meantime, this driver has already quite some Git history, so the question is even, should we send it in with all this history, or do people then say, nah? So that is here, of course, amazing contributions. And yesterday's more main channel, right? This proc dev debug fs, and some news sites said the biggest innovation is community, and that certainly is not really innovation, but certainly true. Amazing stuff when you start something and other people make it even more amazing, as Risto Venef did. And their contribution actually didn't build for anything but x86 and ARM, which obviously we catched compiling everything. And I even mailed them back like, yeah, but by the way, this stuff breaks. And so we need some, because they use some built-in Parity, which is in the other patch. So that is, of course, an amazing thing of, hey, I don't even have to do it myself anymore. I become an open source manager here, live on this channel. So, yeah. So let's get started. So this also means I previously, because how many even freaking files are this now? So our Linux kernel package gets a little bit out of hand, because why is so much stuff broken upstream? Why do we need to carry all the burden of all the fixes of making the best Linux distribution? So previously I YOLO'd that into that here, and that was of course not amazing. I was pointed out that obviously that alters the GitHub history, which I still need to guru meditate about how they want this. And so yeah, so this are this. So let's split this properly. So let's delete all of this what we previously merged. So I mostly merged this in one file, because we have already 63 freaking files. And now we need, so I have saved from Emacs, of course, because where else do you do email, right? Not that Thunderbird would work, or so. Or would have it's like 2023, it's not like Thunderbird would have a working search or a white space damage in patches. Of course you still use mu like 20 years ago. Leave in the comments below if you ever used Emacs, Emacs, mu or VM or whatever. So move home, I saved this already, so that is SPD. Should be SPD. Ah, this was clever. This was very clever. SPD and Parity. This is actually, I still need to work on my storage area network of not SCPing everything. That is a result of using your Steam Desk as a thin client. And, so that can go maybe. Do I even have an account there? Oh, I have. So yeah, so let's max the 70 files. Can have, it's like, yeah, everything is a file. A couple of patch files. So move SPD. We somehow need to sort this in here, and the Parity. So we need to sort this, unfortunately, by number, which is a little bit annoying, because our system, like many systems, applies stuff in alphanumerical order. So yeah, so obviously 1 and 2 is like How do we do this the most clever? Let's see, I believe, let's see if underscore sorts last. So let's move that to, let me quickly, yeah, so this is also improvements. So 1 of 2, 2 of 2 does this. Okay, the sorts, hopefully in all, I mean we use C or whatever locale, so hopefully, also right now I might use ENUS. Oh no, I use C or UTF-8 because we are modern. Right, so that probably should work, and then we need the parity. Let's see if the parity stuff, let's call this parity, transfer, one of 2. Let's see, does that? Okay, this does of course not. Oh, maybe with, like, yeah, 2022, and you need to puzzle the sorting of a bloody patch files. Which, okay, this sorts by pure chance, and yeah, ASCII sorting, right? Numbers, if you know ASCII codes, 30 something, 40 numbers, then upper and lower case characters. If you ever wondered why the sorting order is like it is. Parity. So then let's see if all this stuff applies. So now this should be all this, all the email headers that we need to get reapply and send this upstream. So that would be all of this good stuff, and so this are the DTT bindings. These are the improvements, and so the next thing is, because I would want to rename maybe one thing here, because they renamed this enable temp right, setting temperature. I had here one nitpick. What nitpick was it? Enable temp right, enable temp alarm rights. Yeah, should have done this instantly. Whatever nitpicking I had there, some very minor thing. So this is a new parity thing, because it turns out the Linux kernel didn't have this very simple parity stuff. That is of course now the complication, right? The author here of Risto Venev asked already, hey, do you have plans to send this upstream? Yes, I had, but now we need to get this parity stuff upstream. Like if we wanted to do it so generically, which it's like here, tiny little SPD 5118 sensor hub driver, it's like introducing the parity stuff. So that might be major hurdles. It's kind of like, don't pollute our parity bit of stuff here, but yeah. I also wonder if I need to, management overhead right now. We need to coordinate that we get this upstream. I'm always like, I need to check with them how they want this, but basically, by the way, did this use this built-in constant P of so did they not use built-in parity for that? So yeah, that is replacing this. This is what failed for architecture, and that is what not better chance than today of one last thing of publishing our ISO testing this. So yeah, let's see if that applies. So previously, oh by the way, I might have a, which terminal here? I might have a modification in this. Yeah, of course I had. Because that we should not need then anymore. Excuse me, I'm a little bit tired, very currently tired. So, oops. Because that is what I quick hacked there. So yeah, let's see what, do we have, by the way, a parallel? Do we already have parallel 32 for, let's try RISC-V 64. Oh, you know what? Oh, yeah, we actually need to try both. Because this has not, yeah, has thoughts already. Maybe I should add such a command line override. Because obviously I want to build this with all cores. Wait, maybe I anyway did this. Does this even? I did this totally wrong, because obviously... No, anyway, it doesn't have this. So, RISC-V 64. And then let's build it into the system that we can reboot and test this. Because of course there's also new Linux kernel rights. Wait a second, let's do this slightly different. Because we need to rebuild this for all architectures, because some potentially, or not potentially, some definitely will have... What is here going on, by the way? Ah. Why is this hanging like that? Questions over questions. So let's check all builds. I'm pretty sure some already built 635. Many of them, like some, many of them. So let's internal build all basically maybe parallel 16 rebuild Linux and some offset this a little bit. Let's, by the way, I might have to still have to fix one last thing. So we have actually ARM. Wait, is it all? I'll turn. I should have fixed that for real. I still have not. That is a little bit annoying now. Probably still don't set the correct link for KCC for Clang if configured. Yeah. Certainly would want to test that. How many do we even have? We have X32. Yeah, I slightly wonder why this is not yet. Probably should have. Maybe I should actually. One more thing. It's like, yeah, it's a recurring curse, right? One more thing, 3 more things, and that is only live on YouTube. We have some more stuff, namely Clang. And user yeah, this is a typical case of I should have fixed this. It's like, yeah, it's this kind of stuff you procrastinate a little bit of, like, yeah, boring stuff, and it's like, yeah, and then you spend more time. Like, yeah, that's boys and girls and stuff where we want to automate things, right? ARM 64. Ah, wait. This is even zoom length is wrong now. Did I even zoom length the usual thing? Maybe I zoom length the usual thing wrong. And that is why you want to automate this. Wait, this build doesn't have clang? Why does this build not have clang? Interesting. Okay, then it doesn't have that. Whatever. And ARM version. So basically, yeah, let's try actually all of them. I have no idea if the big endian stuff will work, but no way like the highway to find out. Ah, something failed. Maybe our patch. Scripts make build drivers. Ah. Let's see what's up there in a second. Oh, this also doesn't have clang. So ARM version 6. Okay, somehow the ARM version. Okay, the ARM version 5 is somehow less feature rich for reasons. Maybe actually we should more swiftly check what's going on here. And that is why we test things, right? What's not tested recurrently, what is not tested is broken. Const parity built in. So yeah, I did not I didn't edit that, so I guess so built in constant, you know what? What? Do I build with clang? What the heck do I even do here? No, I don't. So that is my system GCC. Because otherwise I thought it's like, yeah, get some patches. Pro tip, where they tested. An expansion of macro Parity 32 in what? There was a this breaks so much to oopsie. Yeah, and that is the difference between build for me and builds for everything. One of the best Linux distributions. So what's happening is most likely that this macro here, of course, like C being C and glorified portable assembler preprocessor, and with this C preprocessor expanding this macro here for this Parity 32 function, which probably can be substituted with this new Parity 32. So potentially, yeah. I mean, we could try. If it's like, yeah, nothing like finding every issue, and that's why we test things, right? Welcome 10, happy to see you finally. Which kernel version are you using on your system? That depends on the Steam Deck. I don't rebuild. The Ryzen 7950X is using 6.3 or so. 632. Right now we're building 636. And yeah. So the thing is, so much to quickly getting this SPD driver upstream, right? Sure, we could initially remove this vendor and product ID parity check and get that in first, because it's like the usual one more thing. Hey, let's quickly one more parity thing there, and obviously this breaks some stuff. So the question also, it should be reviewed whether this particular parity function is even fully compatible, so that is no swap needed for counting ones. Return. Okay, I believe this is a simple check for odd number of ones. So that, as far as I've seen, that should be identical to the other one. Fingers crossed. SPD, what it was our naming scheme, 5118. Parity 3 of 3 or so. Let's try this. Basically, yeah, let's build this here again, because I want my system, built-in system, init RD and stuff. So while the Ryzen rebuilds that, let's ln sf clang to ARM, and the same for ARM version 7 tools. Like, obviously this should be automated, right? It's not. Don't try this at home. Automate, be more clever than we on YouTube. Automate stuff instantly. So this may or may not work, and then let's, you know what, theoretically we could wait, you know what, let's shortly wait for the kernel to be built, because can we get this into the, you know what, let's, yeah, okay, fine, it's fine. By the way, I probably should double check that this patches parity are also renamed this slightly wrong, but so it doesn't change much here. So yeah, that is how you get a 69.5. Is it with, let's see, is that 68? Maybe that was including a dot or so, or dot and dot dot. Anyway, let's see, do I have on this machine my kexec helper? Yes, I have. And then we kexec this live and hopefully call it a day. And yeah, currently here, right, the only constant is change and regression, and what's not tested is broken. And also probably the author here of Risto Venev probably compile tested that, but not on Broadcom ARM, right? So yeah, so the only substitute for testing is more testing. And why every developer who test builds us probably has a 1 in 1,000 chance to find new breakage as Linux kernel stuff. Yeah, did I already have a... So yeah, the question is, yeah, who sends what and so on. Did I have here a signed off implement like, yeah, management overhead, right? Like, write a nice description that Linus Sebastian Torvalds likes. Implement or add SPD 518 compliant memory SPD hub EEPROM and temperature so then some signed offline. Let's steal it from here, not to have typos. What was it? Not was any. Okay. Signed off by us. Oh, come on. And by the way, which email address did I, or none? Let's see if we can get it through like that. That is the style I usually use. No idea if they will like that or not. Okay, Linux kernel build. Then let's kexec 636 T2 and zinc. So that's usually you can just reboot, but that is a slightly older installation that doesn't have the necessary system built-in glue for that. So I'll check, two fingers crossed. Whether it comes back alive or not. And it does. 636 mod probe. And it still works. 44, yeah, my memory gets a little bit warmish and stuff. So then let's internal build all, rebuild Linux parallel 16. What else do we need? Sleep. No idea what's the default time. Let's use 3 minutes. So that is between the staged builds, not to overload. Also in the meantime I run this RAID 0 to NVMe drive swap and stuff. So yep, let's see what happens. So that is building x86-64. And yeah, that correctly deinstalled, because what my script does is deinstalling the stuff previously. So yeah, one more thing done, which probably took 30 minutes. Yeah, and if I'm joking, like, well, I'm not sending more stuff upstream because, I mean, the amazing stuff is that they implemented this Parity stuff, which certainly saved me an hour or two. And yeah, the only drawback is management overhead, which is like, yeah, if you're an open source manager, then you get into management overhead. Yeah, this basically recurring theme, this open source efforts of 100,000 developers, if not more, over the last 30, if not 40 or 50 years, is highly underappreciated, especially with all the surrounding testing, documentation, and certainly maintenance, new drivers. like everyone always thinks Intel and AMD and all the big mega corporations do the drivers. No, they don't. Even the temperature drivers they barely touched or didn't even implement and stuff. And like sure, they contribute some things, but not everything. And even the AMD Vulkan driver is not their internal, not yet open source driver, but the open source re-implemented efforts. So, and yeah, stuff takes time, right? This is basically, it's pretty rushed. And so on top of this, we still have all the management overhead of now firing off some emails and getting in sync who sends what, and so on and so on. Plus, so it's easily another 30, if not 60 minutes, another day. So that is x86. We could, so maybe actually wanted to. Yeah, the problem is, do you wanna see this? 10 moved. So you're interested in DDR5. So if you want to test this out, this patches RNT2 and the new patches will be there in a second. So that's our Linux kernel package here, which also is not that, but that. So yeah, you can grab the patches and rebuild your kernel if you want, like if you have DDR5 and want to read its SPD EEPROM or the temperature. Oh, I obviously, so yeah, the reason I did this also, I mean, obviously I wanted to know my temperature because it's my first DDR5 system, 7950X here. And so it's getting a little bit warm, right? So, I mean, now it's 50 degrees, 48 and 51. I should, by the way, so 53, where would be, so 50, 50, would be interesting to know which one is which. If one is, if the cooler one, 53, yeah. I mean, it should it or should it not? I mean, you never know what BIOS vendors do. Yeah, theoretically, I could determine that by removing a module and see which address is still in there. But maybe I should also document that. If, like, maybe I should actually, on top of this YouTube channel, on top of running Linux distribution and company, don't delay, maybe try our commercial products or embedded server and virtualization services today. Maybe on top of this, I should also have a accompanying blog where I actually document stuff like what nobody else documents, like which memory slot usually probably matches to which I2C address or I3C address. So this stuff gets a little bit warm, and both have alarm set, right? The alarm is right now 60 degrees. That is managed by the SPD 5118 microcontroller there on the SPD hub. And so it sets the alarm, so that means it reached 60 degrees. I believe this alarm might not be permanent. I changed this previous, or did I? Wait a second, what was the, or was original alarm 55? No, I forgot which was the original alarm. Let's clear the alarm. Let's set it to 65 degree because the current alarm anyway trips. So there's that one, and is it 0 to 0 or write your own driver and then don't remember whether 0 is to 0. Did this clear the alarm or 0? Yeah, that cleared the alarm and set it to 65. Because yeah, so basically, I mean, having alarm of 60, like basically having this alarm constantly trip makes no sense. I already decreased the voltage a little bit. I have this a little bit overclocked, right? These are 96 gig modules of 2 times 48 gigs. I overvolt and overclock them, obviously. So yeah, and I have a Noctua fan in front of the modules. But yeah, my liquid air loop obviously runs on full. It's like, yeah, it's getting summer, what you're expecting. And I have additional 12 or whatever centimeter Noctua fan hanging on in front of the I don't know what it, anyway, so yeah, that's basically good to know, right? Because previously for the first 6, September, October, November, December, January, February, yeah, the first 6 months I was basically in the dark how hot these modules get, and I would say that, I said it before, I say it again, it's really lazy from these big manufacturers, Intel, AMD, but also Micron or Hynix and Samsung and Corsair and so on. They make bloody RGB modules and whatnot and all useless Windows stuff, but nobody, like, can they not donate to our channel? Like, basically, why? Yeah, 2023 we need to reverse engineer and bring our own kernel drivers for knowing how hot our precious expensive DDR5 memory gets. I understand they can't write drivers for each Temple OS, but I would in the meantime expect, especially with all the server usage, that such drivers should be available on launch day. And the AMD launch was later, that was September, the Intel launch was earlier, so that was probably a year ago, probably over a year ago. So yeah, that in my opinion, such basics and not intellectual property, top secret things should be done by the industry. It is hilarious. Like, they all want our money, and then also want that the loose kernel driver writes their own drivers because they're lazy. Anyway, so yeah, we tested, so we are still testing that. So the problem is, maybe I should have done this slightly differently, because what is this like second, because that x86 builds we already know. What is the second kernel is, I'm usually playing OpenRISC. Basically, we probably should build some ARM. Wait, ARM did build. Let's build PowerPC 64 LE. Just because. Anyway, it probably builds. As always, hope you enjoyed this, learned something. Don't forget to like, subscribe, Patreon, YouTube membership, or anything in between. Or have a good day or night, and hope to see you soon for the next fun, cool stuff to come. Like sending an upstream. Oh, I also, you know what? One more thing, let's commit this for those in the audience who want to actually use this. Like maybe on their Power 11 or so. What is the latest? Maybe do they have 12, 11? Do they have DDR5 already? Here's microarchitectures. Here is some Power E1080 server designed to support DDR4. What? But also can use the next generation DDR5 to run access memory technology. So you have it. Power 10 maybe? 1080? 10? When is it? 2022? 30 cores, SMT8, PCIe 5 and DDR5. What did we want to do? Alright, we wanted to commit it. Right, let's do it manually, not to stuck a copyright note under the on top of the email imported patches. I mean, we could, yeah, it's fine. I mean, we could. We know we don't have the build error anymore, but what is it even? Wireless? Do we have? We don't. All of you also always copying some signed off line because I don't want to have typos in there. maybe I should, you know what clever people would of course do, define their Lisp function to have a key binding, right? So there you have it. And then you want the cake and eat it too, so split and imported new SPD 5118 additions or contributions as well as new So, there you have it, playing along at home, as usual. And again, I hope you enjoyed this and learned something. This is also built, and PowerPC64LE also builds. Bit of a shame we will re-delete this, but yeah, don't forget to subscribe, maybe Patreon, GitHub sponsorship, and see you next time for all the next fun stuff to come. And take care.